on. And then going back to my presentation. That's unfortunately how Zoom works. You will also receive a link to all the presentations that you will see today. So we will show you lots of information. You will get that in your email after the webinar. Move to the next one. So the format of today's webinar is as follows. We will start with an introduction that I'm doing right now, followed by a very short update on some recent news, upcoming events on today's topic. We then have a great lineup of 4 expert speakers on the topic of space for energy. And that is followed by sort of a sneak preview of the upcoming Horizon Europe funding calls by a resident Horizon Europe specialist, Linda van Duivenbode. And these presentations will be followed by 3 one-minute pitches, where we have 3 organizations that are active in the space for energy field that will introduce themselves. And after the webinar is over, we'd like to invite you to continue the discussion in our online forum that is available 24/7, and I will explain more about that later. So before we start, let me very briefly introduce you to our host organizations, dotSpace and Eurisy, starting with dotSpace. dotSpace is an open innovation platform that brings together space data and non-space sectors with the aim to share knowledge, to share best practices, and to encourage collaboration and business opportunities. You can find more on our website, groundstation.space, and on our social media channels. And after this, I would like to hand over to Cornel to tell us more about Eurisy and the topic of today.
Thank you very much, Remco. So I will try to share my screen right now. You should be able to see it, I hope.
Yep.
Okay, perfect. So let me get into presentation mode. Okay, so very briefly, an introduction to Eurisy as well. So you're probably already familiar with our organization if you have joined our previous sessions. But so very briefly, our mission statement. So we are a non-profit association based in Paris, and we try to connect end user communities with space space services, so satellite-based services. So we try to promote satellite-based applications and try to communicate about the benefits for our daily life. And we organize events for that. So we try to connect these companies together with communities that are out of the traditional boundaries of the space community and space sector. So we organize events, we publish articles and reports, and we also inform. So we provide feedback about potential barriers that would limit the uptake of satellite-based innovations and services. So that's in a nutshell what we do, and you can find more information about Eurisy on our website, and of course you can follow us on the social media channels. So our members mostly include space agencies, so national space agencies across Europe, as well as the European Space Agency. So if you see that you're not that your country is not yet represented, please feel free to reach out to us as an organization. And even if your country is already represented, just feel free to contact us. You can find our contact on the right, or on the top right of my slide, or otherwise you can contact us through the website. So previously on this space space for climate series, we covered on our first session we covered the topic of plant health and biodiversity. Our second session was about maritime activities. So we talked about coastal monitoring. We talked about the detection of illegal fisheries. And today the format is the same. So we will invite, or we will talk about or show you the different perspectives. So one from government, one from education, and then some businesses that will present their case. And today the topic is all about energy. So you probably heard about the EU Green Deal. So the European Union tries to, or aims to be climate neutral by 2050, which is going to be a huge challenge, of course, because today we have only decreased our greenhouse gas emissions by 20%. So there is still a lot of work to do. So the need is to transform our energy system. So we try to really from today's rigid and linear energy system to a more integrated system where also consumers can be producers of energy. And yeah, of course, energy is a big chunk of our greenhouse gas emissions and accounts for 75% of the total greenhouse gas emissions. And how can space contribute to this transformation or to this decarbonization? Well, on different levels, of course. So we have the different satellite applications. First of all, Earth observation. And also a few years ago in 2018, we had, as Eurisy, we had this workshop around different applications provided by satellite-based services. So you can find the link here on the slide, which will be shared with you. And of course, there will also follow a recap article of this session following probably next week. So we will inform you about all of this. So for now, just a short introduction of what space can do for the decarbonization. So first of all, Earth observation, yeah, it's relevant for infrastructure maintenance, of course. An example would be vegetation that can interfere with electrical grids, cables, for example, trees overgrowing cables. Ground displacement, of course, also weather forecasting. So today we will have a few examples of wind models, so for offshore energy, also for solar power. And of course, there's also the aspect of space weather. So you probably heard of the Carrington event, which took place in the 19th century, which was a big event, solar wind geomagnetic storm, which if that would happen today, it would be a disaster for our networks. So that's also important that we monitor that carefully. So also satellite navigation is also very relevant. So for positioning and timing services, for autonomous vehicles such as drones, so tracking and tracing services. And finally, we also have satellite communication services. So these can also bring added value to the whole digitalization and the interconnectivity of our energy system. So they can serve as a backup, for example, when terrestrial systems are down. And of course, they will also play an important role for the 5G transition. So hopefully we will cover a lot of that today. But before we get to our speakers, I would like to give the word first back to Remco. So Remco, please go ahead.
Yes, thank you very much. I would like to introduce you real briefly to some news items and to some events that are relevant in the area of space for energy. So let me quickly run through a few news items. We saw just before New Year the Copernicus and Galileo Masters. I hope that you've seen some of it, but two of the winners of the 2020 edition were in the energy field: Tradewind, supporting smart renewable energy investments, and Flucto, a Galileo Masters winner who use GPS data or Galileo data to track offshore wind farm components. Have a look at those if you haven't heard from them. Then recently, the University of Twente, which is one of the dotSpace partners, published a new study where Earth observation data was used to help track subsurface geothermal flows. So another very interesting use of space data for renewable energy in Kenya in this case, and you will receive this link later if you're interested. And of course, we saw the record-breaking launch on SpaceX last week, the Transporter-1 launch that took 143 satellites into space, including the GHG set. GHG stands for Greenhouse Gas Monitoring. It's a Canadian company that sends satellites into space that very specifically monitor emissions from point source oil, gas mining, and waste processing locations. Very interesting in for example, methane emission monitoring. Then events, we have IGARS in Brussels, the International Geoscience and Remote Sensing Symposium taking place in July. And we have a quick heads up for the next session, Space Opportunity for Climate Challenges by Eurisy and Ground Station on the 3rd of March, where we'll look at forestry. So with that, I would like to hand it back to Cornel to introduce our speakers of today. And we still
Yes.
haven't connected Cornel with our first speaker, so perhaps we should
Okay, no
change
problem.
the sequence, start with the second speaker for today.
Perfect. So we will start with Marion Lafuma. So she holds a BBA obtained at the ESSEC Business School, followed by an MBA in Operational Management and Sustainable Performance. So Marion joined Reuniwatt in 2011 when she launched the company's Mauritian subsidiary, and she's now part of the Parisian office where she is in charge of the firm's business development. So Marion, please, you can now present.
Okay, thanks a lot. Hello, everyone. Well, thanks, Cornel, for the introduction, and thanks, Remco, also for inviting us today. I'll be talking about Reuniwatt and what we do in terms of space for energy. So we're using satellite data, and I'll show you how we use that data for solar resource assessment and forecasting. Maybe just a few words about us to begin. You might not all be familiar with Reuniwatt. We're a French company that was created 10 years ago on Reunion Island. So Reunion Island is a French territory, but it's in the Indian Ocean, so 10,000 kilometers away from mainland France. And one of Remco's questions was, why Reunion Island? Well, actually, because it was one of the first places in the world to achieve 30% of renewable energies in the energy mix, which is actually a threshold which was set by the French government anyway, saying that if you go beyond 30% of renewable energies, which are variable, you might endanger the grid. So Reuniwatt was created to provide solutions to go beyond 30% of renewable energies in the mix. And therefore, our specialty is solar forecasting. But we also provide cloud observation, and I'll show you what we do, how we use the satellite data to do so. Just to finish with Reuniwatt, today we're present in about 45 countries all over the world. Satellite data enables us to provide solutions anywhere on the planet, so that's great. And we have strong R&D involvements with more than 300,000 hours of R&D to put in place our different products and services. So today, to talk a bit more about how we use satellite data for energy purposes, we actually use real-time satellite information providing from 5 geostationary satellites to cover the entire planet. So MSG Prime, MSG IODC, Himawari 8, and then the NOAA satellites goes east, goes west. And we have a complete Earth coverage. Depending on the different geostationary satellites that we use, we have new updates every 10 to 15 minutes. And the great advantage is that the data is available anywhere on the planet without installing hardware. What we do with those data, as I said, we can both provide a solar data assessment, so using satellite archives and real-time data, and we can provide solar forecasting. I will go into more details about the method really quickly still, because I don't have much time, but the interest of using such data for solar energy, as you can see on this slide, well, using past archives is important to assess a site's solar yield, and therefore before you construct a solar plant, you need to be sure that it's a good place to set it up. For real-time monitoring purposes, it's important to have access to real-time satellite data because it can help you assess the performance of your plant without installing any hardware, once again. And forecasting is something that is very, very important and crucial for grid optimization, in the sense that by knowing how much solar will be available in the coming hours, well, you'll be able to pilot your plant, and transmission system operators are able to also adapt their power production for the next hours. It's really crucial for all the stakeholders in the solar value chain. This is the method that we use, that we have put in place for solar assessment. So past data and real-time satellite monitoring. We use, as I said, real-time data, data issuing from geostationary satellites, as you can see. We obtain a raw image, and what we do, and our expertise is really there, is to extract cloud features. So we really look at where the clouds are and transform this into a GHI map. So GHI stands for Global Horizontal Irradiance. It's the amount of sunshine that hits the solar modules. This is really what we are looking for within company. And as you can see, the method here is obtained through MODIS data, and also we compare a satellite image having cloud index, cloud features, with a clear sky model to really be able to extract a GHI information. And our forecasting solution, well, it uses the SunSat methodology that I've just presented, and it goes beyond in the sense that we're using consecutive satellite images to look at how the clouds are moving. We put in place cloud motion vector fields, and we see how they will move in the coming hours, up to 6 hours ahead. So this is a very short overview of what we do, but if you're interested, please reach out and I'll be glad to answer any questions or go into details if you have forecasting needs. Thank you.
Thank you very much, Marion. And I would like to remind also the audience that if they have questions, they can always use the chat or the Q&A tab you should have on the bottom, I think, on your screen. So please, if you have any questions, use these options. So now let's continue to our next speaker.
We do have our first speaker now with us.
Okay, perfect. So I cannot. So do we have Harald with us?
Yes, we do.
Yes, I'm here.
Okay, perfect. All right, great. So let me just quickly introduce you. So Harald Wagamlink, he is a senior R&D project leader at the Breda University of Applied Sciences. He works on the design, use, and evaluation of simulation games for policy analysis, decision making, management, and organization. And a particular project he leads is the MSP Challenge simulation platform. So it's a software for maritime and marine spatial planning, helping decision makers, stakeholders, and students understand and spatially plan a sea basin in a collaborative way in support of the maritime blue economy and marine environment. So please, Harald, you can now continue with your presentation.
All right, thank you very much. Thank you to both Cornel and Remco. Apologies for the issues I had, all my fault.
No problem, no problem.
I'll just share my screen and get this presentation going. I hope it all works.
Yeah, we can see it, perfect.
Okay.
You're good to go.
So yeah, thanks for that introduction, and good afternoon to all of you. I'll be talking about the MSP Challenge simulation platform, MSP standing indeed for Maritime Spatial Planning or Marine Spatial Planning. So as the background of this first slide suggests, spatially planning the sea, right? Which is a very interesting and relevant topic for this webinar, because a lot of the renewable energy developments are going to take place at sea, at least for the North Sea. And this is where, yeah, we have something to offer with this simulation platform. So as mentioned, I work for Breda University of Applied Sciences, which is a medium-sized higher education institute in the south of the Netherlands, Breda. And we specialize in a bunch of domains, including games and media, which is where I work for. Yeah, indeed, as an R&D project leader and researcher. So I'm going to show you just a little bit the MSP Challenge simulation platform. It's available for everyone to try out at any moment through www.mspchallenge.info. And basically what it is it is a multi-user client-server application in which you can log on to an actual sea basin with lots of data running in the background to just spatially plan with a bunch of people together that sea basin, so the North Sea, for instance. So let me just open it up for you. I've just opened it up here in this window. the North Sea edition of MSP Challenge. So basically what you're seeing here right now is the North Sea, and I can pan over this map, and I've got lots of different data layers at my disposal here, including data that is actually derived originally from Earth observation satellites. For instance, wind speed raster data was derived at one point originally from Earth observation, just as wave height and other kinds of data in this direction. But of course, the value of many of this Earth observation data is actually in its combination with other kinds of data. If you're looking at policy making and decision making in this case for spatially planning the sea. So we've combined all this kind of data with data on where are current offshore wind farms to keep it topical and stay on target with energy. But also data on where are offshore wind farms being considered for development. So as you can see here, we've got lots of search areas, as they're called, off the coast of the Netherlands here. And the Netherlands is going to push hard for offshore wind energy development in the next decades, surely. Yeah, many other countries are doing the same. It's very important parts of the transition to renewable energy strategy to develop offshore wind farms. So I just wanted to briefly show you what MSP Challenge offers in this direction of offshore renewable energy planning. I can just show it by drawing a little bit. So what you can do in MSP Challenge is you can draw up spatial plans, in this case, a wind farm. And I'll just briefly call it a wind farm. And it's for some time in the future. This is a spatial planning tool, right? So that's dependent on, yeah, the future, and what you want to see happening in the future. So yeah, what I can do is I can say, well, we've got this search area. Let's try and develop it completely, or well, not completely. Let's just develop a chunk of it. And as you can see, we've got a simulation running in the background, or a little model that already suggests, well, of this particular size, that will be 4.48 gigawatts max capacity. And as you can see over here, with these existing wind farms, what you can subsequently do is look at the complete energy infrastructure you would need to get all of the max capacity of your wind farm to your national grid. So what's the capacity of your energy cables that you need? How many of the cables would you need? What's the capacity of the so-called landing station or landfall point of your energy infrastructure there? And where would you actually want to develop that further? So yeah, in the interest of keeping it short, I just wanted to mention that very briefly, and mention that the MSP Challenge simulation platform has been in development now for a number of years, and we're continuing its development. We're looking forward to expanding also on these energy options or functionalities in MSP Challenge. For instance, attaching to models that can calculate the cost of energy infrastructure developments just based on a number of assumptions, or attaching simulations and models that can show you the risks to shipping, for instance, with the development of all these wind farms all over the place. So that's just briefly an introduction to MSP Challenge, the idea of having a multi-user simulation platform for spatially planning the sea, which includes energy infrastructure. That's it.
All right, thank you for your presentation, Harold. It looks very cool, and I think it's a very engaging tool to have. So again, I remind the audience, if they have any questions or remarks, just use the chat or the Q&A. So indeed, let's stick to our time and let's move on. So to our next speaker. So now we have Arnoud Vandenberg. He is a business developer at Orbital Eye, and he has a master's degree in business information management from the Erasmus University of Rotterdam. And at Orbital Eye, he ensures the smooth fit between market and industry needs and technology. So Arnold, please, you can now present.
Yes, thanks for your introduction, Cornel. I think you can all you're all able to see my screen now.
Yes,
perfect. Great. So today I'm going to tell something more about like safe transportation and distribution of energy, and how we use a satellite-based technology for doing that at Orbital I. As you all might be aware, energy is transported through a complex energy grid, and whether energy is coming from renewable sources or from traditional sources such as oil and gas, they all need to be transported to the end users. And yeah, this is done through a complex energy grid now, but this will also be done in the future. Energy will still need to be transported either through the current energy grid or to an extended energy grid. An example of this is the plans for developing a European hydrogen infrastructure. 11 large gas companies in Europe are planning to develop this infrastructure. In 2030, they want to have 6,800 kilometers of hydrogen infrastructure. In 2040, they plan to have 23,000 kilometers of hydrogen infrastructure, and 75% of this network has to consist of modified gas pipelines. So pipelines that are currently used for transporting gas will then be used for transporting hydrogen. And at the same time, the largest challenge for transporting and distribution of energy are leakages. Leakages can have like very disastrous outcomes. Sometimes they just have small outcomes, sometimes they're very large outcomes, but yeah, it is something that you want to prevent. It's very essential to prevent these leakages. And then if we zoom in a bit on how these leakages are caused, we've seen that the foremost cause for leakages are external interferences. And with external interferences, you can think of excavation, digging, or building activities. So it's quite important to monitor your energy grid to see which activities are going on around this energy grid. And if you do this, you can prevent incidents and leakages. And if you do this, you can ensure the continuous supply of energy. You can prevent accidents, and you can also reduce harmful emissions. This is especially applicable to gas pipelines. If something happens to these pipelines, the outcome of this leakage can be quite harmful to the environment. And companies are also aware of this, so they already inspect and monitor their pipelines. Currently, this is mainly done by helicopters or by field inspections. This week, I spoke to a Belgium pipeline operator, gas pipeline operator, and he told me that they are monitoring their gas pipeline 6 or 7 times per week with a helicopter. And yeah, as you can imagine, this is not very sustainable. This is not a very sustainable way of monitoring. So that's why we at Orbital I have come up with a different monitoring method, which is based on radar satellites and optical satellites. And to tell a bit more on how this works, so these radar satellites, they're passing over the energy grid every few days, and you can see in this slide that the radar comes over. There's nothing, there's no activity on top of the energy grid, and all radar signals are bounced away. You get this radar image. But then the next time that the radar passes over, this can be like 2 or 3 days later, there's an excavator machine on top of the energy grid, and it gets back a different signal. And then we at Orbital I use this signal to detect changes, and we compare these two radar images. They're quite hard to interpret for human, but the computer is quite good at it, and this results in such a change detection image. So these change blobs indicate that there is something happening on top of the energy grid. But as you can imagine, the radar satellites picks up a lot of different signals in the energy grid corridor. You can see on the left image all these red dots. They're all changes in the energy grid corridor, but not all of them are really threats to the actual pipeline or the actual energy grid. For example, a car which is parked quite close to the energy grid is not really a threat, as it does not harm the pipeline, and it cannot cause any leakage. So that's where we use artificial intelligence and also classical filters to filter out these irrelevant changes. And in the end, this is what we see. So these changes could potentially harm a pipeline, for example. And if it's really close to the pipeline, then it's something we report to customers. And this is an example of how we report it to customers. So this is a screenshot of our application. We have a customer in Trinidad and Tobago in the Caribbean area. They have a gas pipeline. You can see that in green. So we give them all the information based on our change detection. And the gray markers are activities that we have reported to them and that are not a threat. Then we also have a red marker in there. That's something that we have reported to this customer. And it is a threat. So then this customer knows, okay, we need to keep a close eye on it. And then we have the orange marker. These are new activities that we detected and reported to the customer. And they still need to check these activities. Yeah, so in the beginning I said, well, we contribute to the safe transport of energy by using our satellite-based monitoring technology. Then how exactly do we do this? First of all, the satellite monitors quite frequently. As I said, it passes over every few days, multiple times per week. So we can spot activities around the pipeline quite often. It's also a reliable monitoring service. It doesn't matter whether it's a sunny day or there's a heavy storm. The radar satellites always do their job. And at the same time, it's also a sustainable way of monitoring. The satellites have zero emission as they are powered by solar panels. And if you compare it with monitoring by helicopter, you don't have the risk of flight incidents. And ultimately, this way of monitoring leads to less incidents in the energy grid, which in turn leads to less accidents, less leakages, and also then to less harmful emissions. But of course, we also face some challenges in implementing this satellite-based monitoring technology. First of all, we face regulatory challenges. For example, if you look at Belgium, there the regulations specify that you have to monitor your energy grid either by helicopter or by car. So it doesn't leave room to monitor it by satellite. Then there's also the spatial and temporal resolution of satellites. Ideally, you want to have like very frequent and very detailed monitoring of your energy grid. And yeah, as I said, the satellites are passing over every few days, but not yet every day. And like very small events, it's very hard to detect this with the radar satellite. But luckily, this is continuously improving. Both governmental institutions and commercial parties are working on improving the spatial and temporal resolution. An example of this is ESA's Copernicus program, which you all might be aware of. And then the last challenge that we also face is that we have to deal with quite a conservative industry. What we've seen is they kind of prefer the status quo and they're reluctant to change and innovation. And this is quite a, I would call it a high tech or new technology. So we often face that companies are not like really willing to adopt such a new technology. And this was in a nutshell how we use our satellite-based technology for safe transport and distribution of technology or of energy. If you want to know more on this, you can send an email to info@orbital.ai, and you can also check our website, orbital.ai.nl. And of course, we're happy to talk further.
Thank you very much, Arnaud. And I saw that we have some questions in the chat. Maybe we can cover these after all the presentations. So first, let's move on to our final speaker, and then we can have some questions. So our next and final speaker will be Peter Chia. He's an entrepreneur and risk security expert with more than 30 years of experience in sales, business development, and management. And he worked for a variety of national and international organizations in the private sector. And he has also worked for the Regional Development Agency Innovation Quarter as Program Manager, Safety and Security. And in 2019, Peter became the CEO of Aratos Systems. So Peter, you have now the floor.
Yes, thank you very much for this invitation and for the opportunity to share some our thoughts about how to deal with XP space data and energy. I want to approach it from a different angle because we saw a lot of applications, we saw a lot of opportunities on what we can measure or what we can get from space data. I want to see how we can space data made more accessible for other people What I mean is that we need to see how the space data can be of added value, maybe to other applications we are never even thought about. So what I see as a challenge for us is that space data can create more insight for renewable energy collection and planning, but we need to increase the usability of the space data. This is something which I'm working on now with a large group of different, let's say, companies. And one of the ideas is, you know, a lot of entrepreneurs, SMEs, and setup can carry out brilliant ideas, and they can create jobs. But how they use data can be maybe even better, or sometimes even be trained into doing that. Because to be honest, it's not only traditional market, but it's also a very technical market. If you look at how space data is used, the complex systems you are seeing is very challenging for in my opinion. So one of the things we are trying to create is we want to offer services. We have some applications we are doing, of course. I saw the grid, smart grid opportunities, the wind, let's say, assessments, all the environmental Earth observation data we're already collecting. But what is really needed, I think, and that's also to stimulate some youth, also stimulate some more people to use our data, is the training of the use. And I mean, not only interpreting, but maybe also using it in ways that we didn't even think about, you know, being creative, being more active. And all the other thing is, and you also mentioned it, my previous speaker, is the market development. People are now looking at this as a, you know, very expensive tool or something we need to buy in total, but maybe we can break it down to little smaller pieces. So what we want to offer as Aratos, and we have a lot of experience on using the data. We have also done a lot of European programs, but we see it will be stuck only to what we say, let's say the proof of concept or the proof of I think we need more than that. So if you look at what we try to do is to be more open in architecture. We want to have it easy to adopt and expand as projects is required. What we see is now is that it's very related to what one or two companies are offering as an application or as a solution. But maybe we need to broaden that more and see it more like Google is doing, a search engine or some kind of other way of using it. And it needs to be available to a lot of hub users or more people. Of course, it needs to be operated by professionals, but still the application itself can be even bought in your own, let's say, living room or in your own on your own space. This is what Arato system is thinking about now, that we think that also for energy and data, and space data in specific, that we need more, I think it's open for debate, but open for discussion also, how we're going to do it, that we can leverage more on what is already collected and see what other opportunities there are for the applications. So in my opinion, and that's also what ground station is standing for, maybe interconnect more, see how we do an easy addition to the newcomers, not we as a competition to each other, but broaden the market and continue to improve, also connecting with technologies like Internet of Things, big data, blockchain, and artificial intelligence. And our idea is, and also what we are planning, is to have a shared lab, or we call it the Space Data Hub, to emphasize it. And we are very closely working, especially on the Space Campus, to realize that. And this is our, because we have our own ground station, we can deliver the data in certain levels. We do it on different approaches, but this is something we like to add. Maybe it's different than you expect, but it's something we like to think about. Thank you again.
Thank you very much, Peter. So indeed, very out of the box, and with that we can close our speaking slots. So now we can open up for questions. I saw that in the chat we had some questions for Arnoud. So these were about resolution and revisit time. So let me just check the Q&A session. So here's the tab. Okay, so here's the first question. Do you think that 10-meter spatial resolution from Sentinel-1 SAR imageries is enough to detect changes on the ground? And what is the smallest change you would expect? Perhaps image fusion can help a lot, as I can see.
Yeah, thanks for the question. So like if I answer what are the smallest kind of activities that we can see, that would be like a container or a truck. So usually when there's just a very small bobcat, for example, that's hard to detect. But what we've seen from previous pilots and also operational services is that usually these kind of activities are also, and there's more material at the site. So when there's like small excavations, there's also something where the workers go to have their lunch, or there's a truck which deliver the material. So we're still able to detect these kind of changes. But if you really talk about, okay, just one person with a small machine working around the pipeline, that's very hard to detect. Let me just think, what were your other questions? Or the 10-meter spatial resolution. So it's enough to detect most of the activities, but preferably, like we're also like watching very closely how this spatial resolution improves, because the better this gets, the more activities we can detect. And if I remember correct, then the last question was about optical images. I didn't present that today, but we also, once we have detected a change with the radar satellite, we also acquire optical images. And in these optical images, it's much easier to see what's going on. But this is not like our core technology, but it's like a technology that can help in analyzing the situation where we have detected a certain activity.
And as a follow-up, maybe I saw a bit of different questions, but always related to the same. So let me just check. So there was one other question. Are you also interested in combining your SAR data with high spatial resolution data, so optical data indeed? And then is there any way to spot leakages from pipelines at sea, since you were showing the islands, perhaps with different instruments?
Yeah, so I think the first question, if we want to combine it with high resolution optical data, that's something that we are already doing. Yeah, we're working with several providers of this high resolution optical data. And like we try to acquire high resolution optical data for every change that we have detected. But then the challenge with optical data is like weather circumstances. So if there's like 1 week of clouds, we cannot deliver optical images to our customers. So that's why we mainly rely on radar satellites. Second question about the activities in the sea, if I'm right. This is not something that we are working on right now. Indeed, you saw an island, but what we detect is only the changes on the island. If something would be happening on the sea, like below the water surface, that's not something that we could detect. Although I can mention that we also have a different project, which is called Marine EO, in which we detect like illegal ships activity. So we are able to detect activities at sea, but it's only like at the water's surface.
Okay, thank you very much for your answer. And then we also had a question for Marion, but I see that you already replied to that. So the question was, no problem. I will just repeat it for the rest of the audience. So the question was, what is the spatial resolution of the cloud index? So maybe you can just come back to that question.
Yeah, of course. What I was saying is that it depends on the location itself, because as I showed, we use different geostationary satellites, and every single one of them has a specific resolution. So there are new generations which have a finer resolution, and some older versions, let's say, which have a less a less fine resolution. So it ranges from about 500 meters to approximately 3 kilometers. And that really depends on the location itself.
Okay, so I think we are right on schedule, so we have to move on to our next chapter, I would say. So I will give the floor back to Remco now.
Yes, thank you very much, Corneel. Yeah, the next section, and I'm not going to spend too much time, as I introduced already, is Linda van Duivenbode, our in-house Desk specialist, who will tell us everything about Horizon Europe and the context of energy. So, Linda?
Yes, lesson 1, unmute yourself. Yeah, thanks very much, Remco. I wouldn't say everything. I'm going to put my screen, because of course it's still, oh, hang on. Is it okay if I do it like this? Because otherwise I can't see my other screen.
Yeah, sure, that's fine.
Yeah, hi. So my name is Lena van Duivenbode. I'm working with the dotSpace Foundation in ground station dotSpace as a Europe coordinator and tender desk coordinator. Just to give you a quick update, last month, for those of you who were here, we were still talking about the Green Deal calls that were launched at the end of last year, Horizon 2020 program. And I just want to let you know that these calls closed officially on the 26th of January, but there was a submission of 1,550 proposals rather. So the EU portal crashed and they extended the submission date for another day until the 27th. And so now a lot of agency officials and experts around Europe are working through 1,550 proposals of each 70-page worth of text. So good luck to them. So yes, we're now moving on to Horizon Europe. The program is still under development in terms of the work program still being under development, but drafts have been circulated. So we are lucky to have a sneak preview in some of them. The first cluster we took out, so Horizon Europe will work with clusters, is cluster 4, which is digital industry and space. And we picked out several topics that are related to energy, seem promising at least for the audience to already start thinking about. And so clearly one of the subjects that will be of importance is resilience under Horizon Europe. And so these two resilience calls are likely to be part of the new work program and calls coming out, if I am correct, around about April of this year. And the first one is to develop digital platforms for small-scale extractive industry, where they're asking for digital platforms that integrate Earth observation data, in situ data, and data modeling, so the combination of different technologies, in order to get better data for management and decision-making during the extractive process of the energy life cycle. Second one is related to mining life cycle. So to develop innovative new methods to analyze Earth observation data, enabling systematic mineral exploration and continuous monitoring of extraction, closure, and post-closure activities. The development and innovation should be built upon Copernicus satellite constellations, as well as airborne and low altitude platforms, ground-based remote sensing, and also including conventional in situ techniques, methods, and field work measurements. So you can see they're really looking for integrated, at least at the technology level, integrated solutions. Under the space program of this cluster, there is a topic that's EGNSS, so that's a satellite navigation topic that can often, of course, also be interesting in combination with Earth observation or by itself, but we're for satellite data broadly, so we wanted to cover this as well. And this one is to foster the market uptake in transport specifically. So applications are asked for to demonstrate the advantage of Galileo and EGNOS, specific features and differentiators for their use in smart and green mobility, contributing to a resource-efficient, safe, climate and environmentally friendly transport system. So those are the three under the cluster 4 I identified, or we identified. Then another interesting cluster, and clearly relevant to Earth observation generally, because it's also climate and mobility, but in this case, we highlighted the energy topic. Cluster 5 for climate, energy, and mobility. So it tells you here what the objective of that cluster is. There are two topics that we identified that are of interest to this particular audience in this webinar. And the first one is the physics and aerodynamics of atmospheric flow of wind for power production. And as wind turbines grow bigger and taller and the blade tips are increasing, more affected by turbulent atmospheric flow features, this zone of atmosphere brings its own problems, and they're looking for data models integrating Earth observation data for flow modeling. So it's a very physics-oriented call. The next one is clean energy transition. This is a clean energy transition partnership, which is expected to contribute to overarching goals of this particular cluster by pooling national and regional resources and overcoming the fragmentation that is currently existing in the energy transition in Europe. So it's very much contributing to the strategic research and innovation agenda of the energy transition for Europe. So those are the main topics we have been able to identify under these two clusters for now. There's another call from the European Space Agency, of course, also always relevant for satellite applications in Earth observation. This one is under the ARTIS program, Space Systems for Safety and Security, and is asking for a feasibility study and demonstration projects, combination of satellite communication and integrating the satellite communication data with other space assets, such as Earth observation. And this one is particularly aimed at small companies, so the SMEs, who get up to 80% funding, or that's possible rather, whereas the standard funding rate for this one is 50%, because it's very much aimed at demonstration projects. So companies are supposed to invest in that themselves. It does require authority from your national space agency before you can submit. So that's something to inquire with your national space agency if you're interested in this particular topic. One I already introduced last time, if you were in the webinar, then is the LIFE program. It works differently from Horizon in that it's a demonstration program. And this time the LIFE program includes a sub-program which is dedicated to clean energy transition. I haven't been able to find much information about it yet, but it will come with its own work program and funding calls. This is positioned after the stage of the R&D project, so after Horizon 2020, Horizon Europe project, where you go into larger scale demonstration projects. Another program that's has been around for a long time and will be continued again is the CEF, the Connecting Europe facility. This is about networks, cross-Europe networks for digital energy and transport. And so the energy part of this has its own budget, and that's expected to have just over 5 billion euro over the coming period 2021-2027. That's more for, again, for implementation projects in the energy sector. Now, I know we talk about grants usually, and of course that's of interest, but I also wanted to show you that as a small company, a startup, a scale up, or as an innovator, so they also work with other types of organizations, there are opportunities that go beyond the grant schemes. So the EIT, which is the European Institute for Innovation and Technology in Europe, has several thematic clusters. We may have referred to Climate Kick in the past. One of the clusters is InnoEnergy, and obviously, as the name suggests, it focuses on the energy system. And I took out these two initiatives that they have. One is for startups, the Highway, startups looking for global impact and a sustainable world. You can apply for support. Support is coaching as well as funding and help in finding investors. And Boostway, which is for scale-up companies who want to enter new markets and are looking also for example, supply chain support across different borders, different countries. So those are the calls and initiatives I wanted to show you today related to the energy sector. So that's it from me for now. Remco, thank you very much.
Thank you very much, Linda. That was very informative as always. So with that, I would like to move to our last section of today, which is the 1-minute pitches, in which we allow basically anyone with an interest in the topic to present themselves. And we have 3 pitches today. And without further ado, I would just like to start with the first one. And Hywel Curtis of SatSearch, can you give us your 1-minute pitch, please?
Yes, sure. There we go. Everybody hear me okay and see my screen?
Yep.
So hi everybody, my name is Hywel Curtis. I'm head of marketing at SatSearch, the global marketplace for space. We are an online platform that is used by thousands of engineers, space engineers, entrepreneurs, researchers, students every month who are looking for new products, services, and suppliers for their projects, their services, their constellations, and just anything related to the space market, really. As a marketplace, part of our work is to find ways of bringing suppliers and end users together better. How do we improve that process? And one of the approaches we use to follow that is to create in-depth content that helps to educate the market on certain categories of technology and their applications for use. And that's actually the reason why I'm here today. So to keep this really short, the pitch is essentially I would like to speak with any of you who'd be interested in discussing the topic of how to bring together the end users and the suppliers in the energy sector. What can we do better? How can each of these 2 parties talk to each other better? What are each looking for? So yeah, if anybody would be interested in discussing that and maybe providing some short quotes or some insights that we can use in a set of educational resources, obviously in return for some sort of promotion of your own organizations and project work, that would be fantastic. And for the space suppliers out there, if you'd also be interested in learning how SatSearch can help you promote your offer to the global marketplace, I'll be more than happy to speak to you. Listing on SatSearch is free, and the data on the platform integrates with various systems across the space ecosystem, and we can talk to you about that in more detail. So I just wanted to also say thank you for the opportunity. So please send me an email, Hywel, H-Y-W-E-L, Welsh name, @satsearch.com. Thank you very much.
All right, thank you very much, Hywel, for this information. We will share your slides as part of the package with everyone, so they will all have your details. So with that, I would like to hand over to our second pitch by Marcel Vroom of H2 Harvester. Marcel, you have the floor.
Thank you. I've just one slide summarizing our idea about double use of agricultural land to harvest solar energy. You probably know that we need all this land to harvest the amount of solar energy or sustainable energy if you want to reduce the fossil fuels. And by using a double land, by moving cars, you can have the growth of the vegetables or the grass for the dairy farmers, and at the same time you can harvest energy. These cars are moving slowly across the land, and the energy is stored on the farmers' premises in hydrogen, which can also be used by the farmers to as an energy supply for later on in the season, like the winter time. Even they can use the heat generated by the electrolyzer for in their processes. The final result is that due to this setup of harvesting hydrogen on agricultural land, we do not need more grid connections. We even can have less congestions on the internet, on the grid, the electricity grid. And for this, we will use also data from several sensors. Like we can build some sensors in the car, underneath the car. We will generate data which can be communicated to the farmer to give feedback about what's going on the country. But also we need some data from satellites or from drones to forecast things that can happen and influence the harvest of energy and the harvest of products on agricultural soil. So this is my first and only slide. You can reach me by www.h2harvester.nl or h2harvester.nl. Thank you.
Okay, wow, that's a fascinating project. I put the link to your website in the chat, so thank you very much,
Great.
Marcel.
Thanks,
Much
Remco.
appreciated. So with that, I'd like to go over to our last speaker, so Francesca Piatto of ERSC.
Thank you.
The floor is
Hi,
yours.
thank you very much. I will share my, of course, it's not working. Okay, I will start without the slide. So I'm Francesca, and I'm from the European Association of Remote Sensing Companies, and an association representing Earth observation industry downstream sector. We coordinate the eShape project, which stands for Eurogeo Showcase Applications Powered by Europe, and it's an H2020 flagship project establishing Eurogeo. This project develops Earth observation capabilities with and for the users, and helps developing research to business activities. eShape raises visibility and understanding of the Earth observation market, and across a wide sector of applications grouped in 7 showcases spanning from agriculture to energy and climate change, aligned with the group of Earth observations primary lines. eShape is a comprehensive community, and for this we intend to launch a second onboarding process, which will be launching potentially in June, in which we will include the most advanced solutions spanning into one of these 7 showcases. And therefore more information will follow for sure. And I hope, Remco, to share my slides with you so you can share them with everybody.
Yes, thank you very much, Francesca.
Thank
yes,
you.
sorry that the slides didn't work, but as you said, we will distribute them with everyone.
Thank you.
So thank you very much to all our speakers and to all our 1-minute pitches. I would like to bring this webinar to an end by sharing my final slides here, if this works. Taking all this away. Yes, by first of all, inviting you to our next webinar. As I said in the beginning, this is a monthly webinar with a different topic every month. Next month in March, on the 3rd of March, it's always on a Wednesday at 4 o'clock, we'll be talking about space for forestry. So in case you're interested in that, then please join us again next month. And with that, I would like to invite all of you to our Open Campus Forum. This is not just a webinar where it ends. When the webinar ends, this continues. Well, we can continue the discussion on our forum platform, and you can go there by going to the groundstation.space website, clicking on the Open Campus tab in the menu, and entering your account data or creating an account on the forum, and we will make sure that we have a section on space for energy there ready. This is an old slide, so it doesn't represent what it looks like right now. But you can log in and you can continue the discussion 24/7 online, and we will keep monitoring that and make sure to connect you with all the experts where needed. So again, thank you to all our speakers. Thank you to the people who did a 1-minute pitch, and thank you above all to all participants who joined us here. We will share the link to the recording. We will send you all the slides, and we're hoping to see you on the forum, and we're hoping to see you next month. So thank you very much.
Thank you, Remco.
Thank you.
Thank you, everyone.
Bye-bye.
Thanks.
Bye.
Bye.
Thank you.
Bye.
Bye, Remco.
Thank
Thanks.
you. Bye.
Bye all.